Okay. Yeah, actually, I'm gonna do, where's that board? Let me see if I can zoom in on the board. Just write stuff quickly. Okay. There we go. If I wanted to sort, I'm gonna do actually sort and search today, an array. We did a 2D array last class on Monday. So there's a couple of examples I do with 2D array. This is actually a 1D array. One of the common things we have in an array sometimes when you have an array that looks like this with numbers in it. Let's say you have a 50, 60, let's say 6, 90, 8, I don't know, 40, 70. That's two. I'll just do one more. And 50. Now I want to alphabetize, sort that list from small to large. One of the ways of doing that is called bubble sort. And the reason it's called bubble sort, you look at these two, it looks like there's a bubble always attached there. You look at these two. If the second one's smaller than the first one, you swap them. So I'm going to swap them. The 6 is going to go up, the 50 is going to come down. Then you look at these two. Is the second one smaller than? Nope, I don't have to swap them. Then you look at these two. Is the 8 smaller than 90? Swap them. Then you look at these two. 90 and 40, swap them. Then you look at these two. 90 and 70, swap them. Then you look at the last two and you go swap them because the 90 is bigger. So when you go through that list one time, all you do when you take the largest number, moving it down. That's all you did. So this is the largest number in the list. It's not alphabetized. You can see it's not sorted there. So what do? Then we come back and do it again. We do it again now. 6 and 50, that's fine. 50 and 8, you're gonna swap them. Put the 8 here, the 50 here. Then we do 50 and 40. Yep, you gotta swap them. Then these two, that's fine. Then 70 and 50, you gotta swap them. Still not sorted. Well, it looks like sorted, but just luckier. All we did, we took the second largest number here now. Next time, we're gonna go and do the process again. We keep doing it till we can't do it anymore. That's called as bubble sort, this method. That's how you alphabetize or sort a list. If you have names, that's how we alphabetize them. So I'm gonna do one like that. Then we'll start looking for searching after that. If I'm searching for a number in that list, I want to know if number 48 is it there. Well, 48, nope, it's not there. Tell me it's not there. If it's there, tell me where's that number, what location, you know? So I'm gonna do a sort and search. That's what I'm gonna do. So that's the plan. Let me actually put this up on the board. And let me open. Okay. Oh, look at the owl there. Pretty. Oh, here we go. Maybe I'll make a function. I'll write a function to sort and a function to search. Control N. Here we go. Let's begin. So my plan is, I'll do this. We're going to actually sort an array. We're going to search for a number in the array. And we're going to use methods or functions. We call them functions. That's my plan for today. So let's begin. Pound include and IOStream. Using namespace. STD. INT main. Return 0. That's it for now. And let me save this one. And today is October. It's April, what? 8? April 8. Okay. Let's create an array. INT, I'm going to put some numbers in it. INT. What should we call the array for name? Let's say this is tests. Let's say, and give it a size. Well, you know what? Let me do this because it might change from person to person. So I'll do this constant, INT, size equals, give it a number, maybe 8 numbers. So this way, if you change your size, make it size 9, 10, 12, you can change that. INT, test or test, I don't know why, I'll go test, one test. And this is an array, so I got to tell the machine that, of size, that's how big the array. In this case, that's 8. And let me assign some values to it. Oh, come back. Equals, curly bracket, let's put some numbers in it. The first number is 33. Second number is 75. Next number is 98. One number is 74. One number is, I don't know, 93. One number is 100. One number is 80. How many numbers do I have now? 1, 2, 3, 4, 5, 6, 7. A couple more numbers. 62 and 59. I think that's 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like 9 numbers, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll make this size 9. I have 9 numbers. So I have this array of 9 numbers. Next time I want to sort the array. I'm going to write a function to sort the array. So let me sort the array. There we go. Sort the array. Then we'll test it to see if it's working. So I'm going to use a function. So let me use a function to sort the array. Here we go. I'm going to put my function down here. Function to sort the array. Since I put it on the bottom, I got to make reference to it on the top. So what I'm going to do when I go to sort the array in my main program, I'm just going to write the word sort. And I'm going to send the array, which is test, send the array, and tell them how big, the size of it.
Did you share your screen? Because we cannot see.
Thank you.
Thank you.
Let's see, where is that share screen? Let me just. Let's see if you can see now.
Yeah.
Let me switch to my program. Where is my... That file should be down there open. Let's see. I hate this dark background. Let me just see quickly here. And let me share my screen now. Share. Yeah, still open. I can see it. It's there. Okay. Down here on the bottom. Okay. So now I'm going to write my function should expect an array from me and a number for the size, how big the array, how many rows in it. So let's write. So notice it doesn't return. The way I set it up, it does not return anything. It doesn't say A equals. If it says A equals sort, that means I'm going to return something. If there is nothing equals, that means there is no return. So my function here should begin with the word void, means I'm not returning anything. The name of it, which is sort, expects actually an array from me of test. Test happens to be an array of integer numbers. So int, I'll call this x, it's an array. Also, int expects a number from me, we'll call it n. So I'm going to send the size, which the size is going to go on location n, and the array here, all these numbers, now will be dropped into x. Curly bracket to open this, curly bracket to close it. So right now, if I go and run this program, I'm going to have a syntax error right at the top because the machine is going to see that and it doesn't know what sort is unless I make reference to it right here before I enter the main program. So I can say void sort expects two things from me: integer, that's an array, and the other one just an integer value. Now I'm good. Or I can take this function. If I take this function, put it on the top before the main program, somewhere here, if you put it here, the whole function, then you don't have to make any reference to it because the machine will know what that is. So let's sort the array. Now, when you go to swap two numbers, let me switch back to my board here. Let me stop sharing. If I have two numbers, now I want to swap them. Let's have this array, this location has num1 in it, the first number, and this has num2. This has a 50, and this has a 10. And you want to swap them. To swap them, the only way to do it is really you need to have a temporary one, empty container. We'll call it temp for temporary. You can move one of these to this one. It doesn't matter which one. The first step is you move one number to the temporary. That's the first step. Step one. So if you move that, the 50 goes there. Next, you can move this number up here. So the 10 goes here. And finally, you move this number back here, and the 50 goes here. So there's three steps. You need to create a temporary location to hold that, move the first number to it, move this one to down, because you already, when you move this to this, you lose this one. It becomes a 50. You know? Then move the third number back there. So I need to create a temporary location here. Let me share again. So let me create int temp here. That's a temporary location. And as I said, you're going to go through the loop many times here. Every time you go through it, you take the largest number, you move it down. So I need a double loop here. 4. int. I equals to 0. I is less than n minus 1. You'll see I'm not going all the way to the end. Because if you go to the end, you're going to compare it with the one after it, you're going beyond. You don't have that many numbers. So it's going to be one less than that each time. And I plus plus. Increment by 1. We go 4. int j. J is less than n minus 1 minus I. Because the second time you go through it, every time you go through it, you want to be one less. It's the first time I is 0. You're going to go all the way. If you have 9 of them, you're going to go 8 compared to 9. Second time, you're going to go to 8. Next time, you're going to go to 7, 6, 5. So that's what this one does. Each time you have one less. J plus plus. And what you want to do when you enter this one, check and see if what? If the value, I call the array what? X at location. If X at location J, the inner loop, the top one, if that one is bigger than, the top one is bigger than the one after it. Or J plus one, not minus one. The one after it, not the one before it. Is that parentheses? Yeah, that's good. If that's true, what do you want to do? Curly brackets to begin. Now we're going to swap them. So I want the temporary location or the empty location to equal one of them. It doesn't matter which one. X of J. I want X of J to equal X of J plus 1. And I want X of J plus 1 to equal the temp, the empty container. That should actually sort the array. Let's do here, let's show the sorted array. Just to see if it's working. Show sorted array. Me to make a function for that? I can make a function. I'll call it show. Oh. Show, that's the name of the function. It's going to be called show. Let's send the array test. And let's send the size. That's going to show me the array. So let's make another function here. Function show array. Void, it doesn't return anything. The name of show, he says, I'm going to call it show. Expects an array from me of integer number. int z, that's an array. Comma, expect a number from me, int s for the size. Curly bracket to begin, curly bracket to close it. Cout. Oh, before cout, I should say for int k equals to 0. K is less than s. K plus plus. Cout. What are we printing? Cout z of k. Then go the next line. That will print the array. Let's see if it's working. We can test it. So it's going to sort the array and it's going to print the array. That's what I did so far. Let me save it. Let me run it. Let me just move this one down. pound include IO stream IOs. Oh, missing an E there, huh? IO stream. And show, oh, because I didn't make reference to this one. Because it's in the bottom. So I got to make reference to it. Here we go. Void show expects an array from me and an integer number. Now I should be good. For INTI equals to 0, I is less than I plus plus. What's the error here? Semicolon expected. Oh, that's a comma instead of semicolon. And here's my array. Is it in order? 33, 59, 62, 74, 75, 80, 93, 98, 100. Let me show it to you before and after. So this is, let's show the array before. I can say show, because I already have the array now. Actually, just copy this line. Show it before you sort the array. Copy. Show me the array before you sort it. Sort the array, then show it to me again. That's actually the advantage of using a function. Is the only problem with that, I don't know where it starts. So I should have a space between them, right before and after, you know? So maybe I'll do this one, see out before, then go the next line. And before you show it to me again, see out after, and go to the next line. So you get to see the before and the after. Oh, double quotation. Hate when it does that. There we go, before and the after. Show me the before and the after. This is the before, and this is the after.
I have a question.
Yep.
Can you explain for the void for the sort function
Yep.
and the inner loop where it says j equals 0? Why do we need the n minus 1 minus I again?
Because when you're comparing, notice you're comparing this location with the one after it. See how I'm comparing? Check to see if that location and the one after it.
Yeah.
So you're not, for example, if you have 9, you're not gonna go to 8 because you'll be comparing 8 to 9. If you have 9, the biggest number is 8 because you start at 0. So that's why you have the -1 here.
Okay, so that keeps it from going to, sorry, could you
Yep.
say that again?
Again, if I have a size 9, right? If I have the size 9, 1, 2, 3, 4, 5, 6, 7. I have 7 on the board. Let me just switch here, stop sharing. I have 7 of them on the board. So when I go to sort, this is location, what did I call the array test? This is test 0. There's 7 of them, that means this is what? Test 6. Yes. So when I go to compare, I'm gonna say, if you said set the loop for I and t, I equals 0, I is less than, let's say I said the size, which is a size 7, right? You want to compare to see if test I is bigger than test I plus 1. Well, if you set it to go to 6, if I can go to 6 because less than 7, you're testing location 6 with location 7. There is no location 7 here.
Oh,
Because you're starting with the 0. So that's why you have to go -1.
okay.
So you never go to the empty one or the one that doesn't exist. And for the second time, when you go through the loop, so that brings the biggest number down. The second time, I don't want to go to 6 because I know 6 has the largest number. So the second time, I want to stop here. And that's where the -j actually comes in. The next time, I'm going to stop here. The next time, I'm going to stop here. So I'm not going to go all the way to size. This is going to be size -1. But for the second time, I want to go -2 actually. For the next one, -3. The next one, -4. And that's the reason why I put -j there or -i.
Okay, all right, I get it now. Thank you.
Oh. Where was it? I was writing stuff there. Oh, it's tough to get that one up there. Okay. I was trying to get the board, but. So now that sort, it works fine. It showed me the array before. It sorted the array, showed me the array after. The next step is I want to actually said what? There, get out. Get out there. This page, get out. Need to get this page out. There we go. So what did it, let's see, search for a number. Okay, so we just sort the array. Let's do search for a number. So you're gonna actually put a number there and you're gonna search for it. Let's write the function to search. We're gonna get a number, then we're gonna go and search for that number. So maybe I'll make the function here. To search for that number, there's a couple of ways to do it. If our list is really small, you just go start with the top, compare it to the first one, and move on. That's called sequential search. The other option is called the bisection method, which is you cut the list in half each time. You go, is my number less than, you pick a number halfway through, and if the answer is yes, then you go, okay, I'm gonna have to look at this half. Then you keep doing it. Let's pick a number to search for. So let's go in the main program here. Let's say I want to search for a number in the array. So this section is going to show me how to search for a number in the array. So let's ask for a number. Cout. Enter a number to search for. So you're going to type a number, and you're going to read that number. So where are we going to put the number? So let's int, we'll call it number. And let's read that number. Cn, put the result in number. That's the number you want to search for. It's the same type, it's integer, the same type as the numbers in the array. You're not gonna switch it to double. If you switch it to double, it's not gonna work. They're different. They have to be the same type. So now let's go through it and see if we can find that number. Let's search. Just thinking here. When we have a function to search for it, that function is actually going to tell me the location of the number. Okay, let's see how I'm going to do it. Let's have him return the number here. So we're going to ask for a number to search for. Now I'm going to go to my search, int. I'm going to return a value here. Results. Equals. Search, that's the name of my function. Search, and I want to give it the array. The array is what? What did we call the array? Test.
Yeah.
Search the array. Also give them the size. And give them the number you're looking for. Number. Give them all these values. Give them the array. Give them the size of the array. And give them the number you're looking for. Now, what I want the search to do is return back the result. Which location is the variable? But what happens if the variable is not there? What do you want to return? So we got to decide, like we got to pick a number, minus 12, for example. If you get minus 12, that means we didn't find anything. Any number you want to. So let me actually write the function here. Start working on that function. So this is going to return a value, int. I call search. That's the name of my function. Expects an array from me of integer numbers. Int. We'll call the array list. It's an array. Going to take the list of numbers from the array. Int is going to take the size. Maybe I'll use S. Let me use L for the array, make my life easy. The size S, and the number we're looking for, int n. Is going to get the array, which is the test will go into L, the size will go into S, and the number will go into N. I'm going to come back and leave a line here. I'm going to find the index. That's what it's going to give me. Where is that? Which location that number matches? Is it location 5 or location 6? But what happens if there is no match? So I'm going to define int index and set it equal, what do you want to give it? Start with location. When I start searching, I want what's in location 0, what's in location 1. Let me begin with location 0. That's the index I'm going to use. But if the position is not there, int position where that number is, and give it any number you want to, like especially negative number. If I give it negative 103, no reason why I picked, or 102, that means I can't find a match. I went through the array and there is no match. That tells me where the position. There's no negative values. The first location of the array is array 0. Second one is 1. Next one's 2, 3, 4, 5. So when I find a match, I'm going to switch this number from negative 102 to whatever that location is. But if it stays negative, that means there is no match. You're not going to make it 0 because the number could be in location 0. And maybe I'll do also Boolean, B-O-O-L, found. Did we find the number? Equals false. We didn't find the number yet. Because if you find that number, if it's true, stop looking. If you know the number in location 5, stop looking. Unless you think you have more than 150, like in this example. Then you want to go through the whole list. This one's going to assume there is no repeat. Like telephone numbers. It's not going to be a repeat. And let's start looking. I'm going to do a while statement here. Instead of do while, I'll do the while. While my index, use capital index, yeah, index, which is 0, less than the size, which is S. So we're going to go through, index has a value of 0. Is 0 less than, let's say, 7? Yes. Compare that location. And at the same time, not found. Found has a value of false. Not found is true. So if it's true there, so what do you want to do? If that's the case, what should we do? We didn't find the number. Check to see if L, the location, the array L, location index, equals what did we call that? We read the score N, the number we're trying to search for. Oh, I gotta close this one. If in the allocation equals the number you're looking for, if that's true, then you want to do two things. You want to do found. Oh, I don't know why I did two of them. You want found to be true now. If it's equal to, you found that number, stop looking. And the position where that number is equal to the index. That tells me where that number is. And if it's not, that means I need to use curly bracket here. I'm doing more than one statement. If not, I want to increment index. Increment it by 1. Oh. Now, if we find a number, position is going to have the number once we find it. So when I return position, that will tell us where that number is, which location, which spot, position what. If it's a negative number, we didn't find anything. If it's positive, we found the number. Need more space here for that mouse. If position has a value of negative 102, notice negative 102, that means we didn't find the number. Because once we find where that number is, we're going to adjust that position. So if it's negative, that means we went through the whole list and there's no match. So now I just got to have an if statement. If it's equal to the negative number, it says number doesn't exist. Otherwise, show us the number. So let's go back to the main program. Now that position is going to be dropped in location result. So result will have a negative 102. So now I got to tell the machine if what? If results equals negative 1 to equal sign equal negative 102, I think we said. That means you have no match. So we'll say C out, we have no match. We have no match. Then go then, oh, I forgot the double quotation. And L. We have no match. Else, if it's not equal to negative 102, that means we have a match. And the number we want to see is whatever in that location. Else, C out, so let's see, what are we going to write? C out. What's in result plus 1? That'll give me the location of it. If you want the number, you want the location. If you want the location, because when you and I count, go location 1, location 2, location 3. So what you want to do here, result +1. We don't count the first one as 0. Because the first one is actually 1. Oh, I forgot the less than sign. Come on. Let's see if that will do it. Might have to adjust something. Oh, shoot. Just looked at the clock there. Oh, I got to make reference to this one. That is called results. Oh, I got a problem here. I call them the same name. I wasn't thinking. I called the function result here, and I called the result there. I got to give them a different name. So let me just give them a different name. Oh, that's the result coming back from them. That's okay here. So this is okay, but let me look at this one, make sure I don't use the same name. Results. What was the error then? Did I make a reference to it? Up there on the top? Nope, that's what it was. INT. And return integer value. What's the name of it? Result, I think, or results. Let's see, results. And expects 3 things from me. INT, it's an array. Expect INT number, and INT the number you're looking for. Somehow we jumped there. Comma INT number. So 3 numbers. I mean, array of integers, the size and the number you're looking for. Let's see if that's okay now. Search. Oh, I called it search, not result. INT search. The array called search, not result. That's why I called the array search. There we go. Enter a number to search for. Let's say number 62. And that's the 3rd number. Is it the 3rd number on the list? Yep. Let's do it. After we sort the list, let's run it again. Let's say I'll do enter a number search for number 93. 93 is which number? 1, 2, 3, 4, 5, 6. Is it the 7th number?
Yeah.
That's a 7. So the spot of that number is 97. Now, what about if you put a number that's not there? It should tell us that number doesn't exist. I can make the output a bit nicer. 15 or 150. You know that number is not there. We have no match. So you can take the list, you can sort the list, they can search it for a certain number, and that will give us the location where that number is. We know what the number is, so that's why I don't want to print it. So I should, instead of C out, instead of just 7, I should say the location of that number, made it more user-friendly. I gotta go, but I'll change it here. Maybe right here. The location of, and maybe I'll put the number here. The number is where? It's called number. That's the one we're searching for. The location of 100 is, now here we go, is and we put that number, is the 7th, the 3rd location, the 7th location, the 8th location. Oh, and print that one here. And I'll go to here. Location. And now that should be nicer.
You misspelled number.
Where?
The location of number.
Yeah. That'll be more user-friendly than just saying 7, 3, 75. The location of 75, I should put a space, is the 5th location. 1, 2, 3, 4, 5. Yep. So I just had space here. Shut up. And that will give me the location of that number. And done. Location of 98. The location of 98 is the 8th location. So we can search for any number. If it's not there, we'll tell us it's not there. Okay. Jesus, I didn't realize it was that late. I'll stop here. And I'll see you guys next